Alright, what's up, guys? So, today we're gonna do number 7 on the review. So, let's get started. Um, One of the Laplace transformation formulas of sine is going to be sine AT equals A over S squared plus A squared. And since this equals the sine of 2t, we're gonna have sine 2t equals a 2 over S squared plus 4, because 2 squared is 4. And so the Laplace transformation for y double prime is going to be S squared y of S minus sy of 0 minus y prime of 0 plus 4. Oh, no, sorry. This is just for y double prime. For 4y, it's just going to be L. Oh, sorry, no. 4y of S. Alright, so when we add that together, it's going to be squared y of S is y of 0 minus y prime of 0 plus 4y S is equal to sine of 2t, which is 2 over S squared plus 4. Alright, so right here, for the initial conditions, it says y of 0 is equal to 0. So S times 0 is just equal to 0. However, y prime of 0 is equal to 1. So this right here equals to 1. So after simplifying, after you take the ys out, it's going to be S squared plus 4 ys minus 1 from this equals to 2 S squared plus 4. Alright, so the next thing we're gonna do is just move the 1 to this side. So it's gonna be S squared plus 4 y of S is equal to be 2 S squared plus 4 plus 1. Alright, so we need to isolate y of S. So what we're gonna do is just it's gonna multiply or divide this over. So it's just gonna be y of S equals to 2 S squared plus 4 this is gonna be squared plus 1 over S squared plus 4. Yeah. Alright, the next step, we need to have the same denominators for these two. So we're gonna do y of S, and excuse me for my bad handwriting, because y of S is equal to 2 plus, so since this is S squared plus 4 squared, we need to multiply S squared plus 4 on top and bottom. So this is just going to be 1 of S squared plus 4 all the way over S squared plus 4 squared. Alright, so once we simplify this even more, y of S is just going to be S squared plus 6 over S squared plus 4 squared. Alright, the next thing we need to do is take the partial fraction with this. So what we're going to do is just y of S equals to AS plus B. The first one is S squared plus 4. So for the second one, it's going to be CS plus D all the way over S squared plus 4 squared. So, after we simplify some more, after we multiply S squared plus 4 squared, we get S squared plus 6 is equal to AS plus B multiplied by S squared plus 4, because you're multiplying s squared plus 4 squared by the whole thing. So plus cs plus d. Alright, dope. So once we simplify some more, this is going to be s squared plus 6 equals to as cubed plus 4as plus bs squared plus 4b plus cs plus d. Alright, cool. So what I'm going to do is just take the terms. So the term for s cubed, the only one in that is as. Oh, sorry, no. It's just a. Sorry, no. S cubed is equal to 0. And the only one with s cubed is a. So a equals 0. Going down the line, s squared. The only one with s squared is b. However, s squared has a 1 in front of it. So 1 equals b. That means b equals 1. For s, we have 4. Oh, it's going to be 0 because we don't have an s in this equation. 0 equals 4a plus c. From s cubed, we already know a equals 0. So this is just 0. And then now we get c equals 0. Last one. Alright, so this is going to be 6. And then this is going to be, what is this going to be? 4b plus d. So we already know b is equal to 1. So when we move the 4 to the other side, it's going to be 2 equals d. So d equals 2. So we need to plug it back into y of s. So y of s is equal to what's y of s? A is 0, so we don't plug anything in. B is equal to 1. So 1 over s squared plus 4 plus c is equal to 0, but d equals 2. So d over s squared plus 4 squared. Alright, so what we're going to do from now is take the inverse Laplace transformation of this whole thing. So we're going to do L of negative 1. I'm going to do this s squared plus 4 plus 2 s squared plus 4 squared. Alright, and one of the properties state that we can just split it up by doing this. Negative 1 over s squared plus 4 plus another inverse Laplace 2 s squared plus 4 squared. Alright, cool. So let's just work step by step here. So for this one, the first one, which is going to be 1 over s squared plus 4. Okay, so from one of the, I believe it was the constant multiplication property of inverse Laplace transformations, it states that, let me pull it up. States L negative 1 multiplied by f of t is also equal to a times L negative 1 f of t. Alright, so from this, we can understand, or sorry, we can just judge it by this 1/2 times 1/2 times 2 over s squared plus 4. No, sorry, plus 2 squared. Alright, now we can take the 1/2 out. 1/2 inverse Laplace 2 over s squared plus 2 squared. Alright, from one of the inverse Laplace formulas, let me write the formula down right here. squared plus a squared is equal to sine of at. So a is going to be 2. So let's put this here. 1/2 sine of 2t. All right, dope. Next one. Inverse Laplace of 2 over s squared plus 4 squared. All right. Like I said before, we can just split it up like this. Sorry. Wait, no. Yeah, the constant multiplication property states the same thing. So we can just apply it here, which is going to be L negative 1 1/8 times 1/8 times 2 times 2 to the third s squared plus 4 squared. All right. We can take the 1/8 out again. So it's going to be 2/3 or 2 cubed plus 4 squared. All right, cool. And another one of the formulas for the inverse Laplace is going to be L of negative 1, 2a third, all the way over s squared plus a squared is equal to be sine of at subtracted by at cosine of at. All right. So this is just going to be, oh sorry, a is going to be 2 again. So this is going to be 1/8 from right here. 1/8 sine of 2t minus 2t cosine of 2t. All right, cool. So now we got both of these. We can just add it together. So 1/2 sine 2t plus 1/8 sine of 2t minus 2t cosine of 2t. All right, cool. Oh, and this is, yeah, another parentheses. All right, so now I'm gonna write it like this. It's easier to see. Sine of 2t over 2 plus sine 2t minus 2t cosine of 2t all the way over to 8. Now we're gonna have to find the common denominator. Yeah, so I'm just gonna multiply this by 4 to get 8. This is gonna be 4 sine 2t plus sine of 2t subtract by 2t cosine 2t all the way over 8. Now we see that 4 sine 2t plus sine 2t is basically 5 sine 2t. And so, yeah, this is the last step of the problem. So it's going to be y equals 5 sine 2t minus 2t cosine of 2t all the way over 8. All right, cool. And I'm not sure if this is correct, but yeah. All right, thank you guys.